Hello everyone, so on this video I'm going to be showing you I'll be showing you different examples on how to use the fundamental counting rule. So for the first one we have James, who has 8 shirts to choose from to wear. There are 8 different options to choose from at the beginning. Once he wears one of the shirts, then there are only 7 shirts left for him to choose for the next day. Once he chooses another shirt, right, then on the following day he's only gonna have 6 shirts to pick from. You can continue this pattern to find the number of permutations. Permutations is like basically the different arrangements that he can make. And we're noticing that on the first day there's 8, then on the second day there's going to be 7, then 6, then 5, then 4, then 3, then 2, then 1. So basically each day we're decreasing 1 because one shirt is being used, right, every day. By doing that, we're basically finding what they call the sample space, right, which is what I had shown you on the previous chapters, right, about the sample space. So here n of s, so the number of elements inside of the sample space is 40,320. So then there are 40,320 different ways in which James can choose and order his shirts, right? Now here's another example. It says there are 5 members in a club. Each year the club elects 3 people to be president, vice president, and treasurer. There are basically 5 people, so we begin with 5 to choose in order to choose a president, right? Now once the president has been chosen, there are 4 different ways to pick the vice president. So one person was already elected for the president position, so that means there's only 4 people left, right, for the vice president position. Now once they have chosen the vice president, then there are only 3 options or 3 people left for the treasurer. So that means that our sample space is going to have 5 times 4 times 3, which equals 60 different options or 60 different ways to choose the president, vice president, and treasurer. Let's go ahead and look at this one's in the bottom. So this one say that you are setting the combination on a 3-digit log. The numbers 0 through 9 can be used. So basically for this one, we're gonna be looking at the different options that we have for each different digit log, right? So let's say for the first digit, we have, let's say 0 to 9, 10 options, right? Times, for the second digit, let's say there's no replacement, so no repetition. So let's say there's no repetition. I think I wrote it wrong. I put a repetition, so no repetition. So because there's no repetition, then the next number cannot be the same one as the first. So if in the first one were 10 options, 1 is taken, so on the following one there's going to be 9. Then on the next one there's going to be 8. And this is going to be 720. So there's 720 different combinations that can be used for this 3-digit log. Now it says there are 15 applicants for 4 jobs. So basically what I want to do, we're going to go ahead and open the 4 slots for each job. Now for the first one, there's 15 options. Someone is hired. So for the second one, there's going to be 14 options. Someone's going to be hired. So for the following one, there's going to be 13. And then for the following one, there's going to be 12. So notice how as we keep multiplying, each value decreases by 1, right? This is going to be 32,760. So then there's 32,760 different ways in which the company can hire this 15 applicants for the 4 jobs. Okay. And again, in both of them, you'll notice that how we are decreasing by 1, right? Well, this is basically what the fundamental counting rule says. Is basically we are multiplying with the number at first, and then as we keep going on the different type of options that we have for the following values, the number decreases by one, and until until we're done with the whatever number of possibilities that are being considered. For instance, for the 4 jobs, there's only 4 possibilities, right? So 4 different slots or different options, right? And then we end at the 4th digit, so 15, 14, 13, 12. We don't go below that. For the first one, there's 3 digits, so we only multiply 10 times 9 times 8, right? However, if we're doing something like in the case with James, where he's wearing all his shirts, then we are multiplying 8 times 7 times 6 times 5 all the way to 1, right? When he's pretty much not going to have any other shirts left. So this is just like a kind of like an idea of what the fundamental counting rule is and how